Hi, my name is Mohamad. This is my assignment demo video for Assessment 2 AGP, Advanced Games Programming. In this, I'm demonstrating procedural content generation. What I am generating is simply the enemy AI from previous labs, as well as a generated power-up ball. I haven't actually put any power-ups in it, but it's just an example for if your game did have power-ups. So to begin with, I will just show a demo by clicking play. Now, the quality of the screen might not be that great, but as you can see, there have been several AI spread out. The yellow balls are the power-ups, and the AI are spread out. Now, I have made the map quite large, so as you can see though, they have all spread out. The further out they go from the origin, the more they're spread out. This would be because of the way I've written the code. As you can see, they don't spawn on top of each other or near each other within an acceptable range. I also wanted to make a note of the PCG methods. So with this is an offline method because it all generates, well, before play or right as you begin in the begin play function. Now, with the degree and dimensions of control, a random seed is used between certain numbers that I've written. It is a generic content because the player's behavior makes no effect on where the objects are spawned or how they're spawned. It is also a stochastic method. You cannot recreate the same content or where they're placed just because it uses a random seed. Now, it is all generated in one pass using certain parameters, so that would also be constructive and automatic generation. Now, the focus of the video would be educational. I will not be showing much blueprints just because I don't use them, or I use them but just barely. You'll see later on in the video. I use mostly the wall controller and the PC generated power-up classes. Now, it's called wall controller because originally I was planning on generating walls and rooms. However, that I decided to change my mind and generate AI and power-ups. But at that point, changing the name of the classes caused a lot of issues, so I decided for stability's sake to keep the name as wall controller. So in this video, when I do mention the wall controller class, I am talking about the class that handles the spawning and the generation. Now onto the code. As I mentioned earlier, most of my generation is handled in my wall controller class. So to begin with, the includes. So I've included these two, but in your own project, what you would need to include is basically the objects you are generating. In my case, which is a power-up and the enemy character, and in your case, if you were generating a room or a projectile, you would need to include the classes of those objects. Now, going down, this is where I've declared the objects being spawned, and then here I have the functions get new x location and get new y location. So these functions, what they do is they generate x and y values for a point on the map where it is possible to spawn on. Then I have these three functions, and what the purpose of these three functions is to ensure that objects that are spawned do not spawn on top of each other, they don't spawn right next to each other. It ensures that they are spawned in a clean manner and that the map isn't too cluttered. And then I have these two floats, which is an empty x value, empty y value. The reason I've named them empty x and y value is because so when the generate x and y functions are called, they get stored into here, and then they have to get checked by these three functions I mentioned earlier. And then if they pass the checks and it's decided that that the spawn point is an acceptable spawn point, then they are used, which is why I've called them empty x and empty y values. Then I have an array. So the point of this array is to record previous x and y values that have already been used. This is just so I can record the locations of objects that have already been spawned, and it makes it easier to find an empty space. Now onto the implementation in the CPP file. Now in the constructor, what I've done is I've initialized the values here just to be empty, and then I have set the size of the array to be 50. Now I only generate 30 objects, which is handled over here, but I made it just bigger just in case I wanted to make it bigger. I wanted to do it for testing. It was just easier, even though I am not using the whole size of the array. Now moving forward, this is where all the generation actually occurs. So all of the generation occurs in a for loop. That's right here. So what the important number here is the 30, and the 30 decides how many objects are spawned. So obviously 30, that's how many objects are being spawned. If I can make it up to 50, and if I wanted to make it larger than that, I would have to change the number here. But since I'm not making it larger than that, it's fine. So then what I next do is I get the empty x value, empty y value, and I use the functions get new x and y location. So if we go down to those functions, now I'm only going to show one of them because they're both the same, get new, get x with the x. The only difference being that one is an x value, one's a y value, otherwise the code is the same. So what happens in this function is I initialize a float value and it's empty, and then what I use is I use frand range to generate a seed basically between these two values. The reason I've chosen these two values is because that's what fit my map. My x and y values both range from -10,000 to 10,000. On your own project, then you would have to put numbers that are relevant to how big your map is. And then what I do here is I go and I add the x value to the number that was passed in earlier. What this does is it just makes the generations move outwards. Now it's not necessary. I just felt that with regards to the video, it would be easier to show the people how objects spawn, especially since I have put in a larger map. Again, not necessary. Just chose to do it for the sake of the video. Now what I do here, as I mentioned earlier, I do run it through some checks. So check if in range, what this does is basically I check if the value is between the values I pass in. The reason I do this is because if you remember up here in my get new x location, I add this to this. Now what can happen is that then the number that has been generated can exceed these two numbers, and that means that it won't actually be placed on the map, which we don't want. So again, it just checks that the number is in between the numbers that are passed in and that will fit on the map. The next check that I do is I check if the point's empty. What happens actually is that I am checking if there's anything nearby, or if anything's on the spot. If there's a distance that's less than 3000 f basically between this and the closest thing and the way I check that is by using this check distance between points. Basically, I'm just checking by running through the array that we mentioned earlier, is there anything there, and then I check if the distance between those and the new point is greater than 3000 f. If it's not greater, once again, we call the get new x location function and we generate another number. And if it passes both these checks, we just return the value and then we move back up here. Now the final task is carried out through blueprints. So you need to make, the first blueprint you need to make is a wall controller blueprint, which has the parent class of the wall controller, or your whatever you've named your generation controller script. And then you also need to have blueprints for every object you're generating. If you already have them, great, as long as the parent class is the script that handles that particular object. Now in the blueprints, when you open them up, all you need to do is for the generated power up, well, you don't need to do this if you've already created blueprints that work fine. All I've done here is I've added a static mesh, and that's pretty much all you needed to do for this. The important thing is in the wall controller blueprint. Now if you recall earlier, I declared the objects to be being generated in the header file, and they show up here. I exposed them by uProperty, and all you do is you click the right relevant one and you make sure you want to click the blueprint option in both, and then you want to compile, save, and that's all you need to do. Once you're done with the blueprint, you want to put the wall controller blueprint, or again your generation handler blueprint, into the world, as that's what's actually making the generation happen. Once you've done that, we click play, and once again, here we go. We've got everything generated. As you can see, they don't generate on top of each other. They have quite a distance between each other, and as you go further outwards, they generate less and less. And they don't spawn on top of objects that already exist either. And they come out pretty far. As you can see, this one's come pretty far out here as well. And that's my demo. Now I will talk about the project cohesion and plan for moving forward. Now I'm going to talk about my project cohesion and plan. In regards to the cohesion, I was unable to work with a group partner just because I work full-time, and it was very hard for me to collaborate when I can't work on his code or look at my partner's code, for example, for like 5 days after he's given it to me or he's completed his part of his section. So for that reason, I have decided to work on this project alone with permission from the subject coordinator. Now, instead, I'm going to talk about my project cohesion. Now, for the first part, I added sensing to my AI, sight and hearing. So, and now I've implemented generation of these AI and or buffs or debuffs, whatever I decide to go with it later. So my plan would be that I click play, and once I've implemented multiplayer in part 3 of this assignment, the aim of the game, well, not a fleshed out game obviously, would be make it to the other side. If you're detected by an AI that is randomly generated, then you lose, or well, you set back while the other player can keep moving forward. And then the AI would be generated randomly, so you have to find a pathway that they can't see, which is not seen by them, and find a way to stealthily get to the objective, which could be, for example, a flag. So that's how I aim to implement all 3 components of the AI, the procedurally generated content, and the multiplayer aspect, while obviously with the other player also trying to reach the same aim of the game. Thank you for watching. That was my video with the focus on educational content. This is Mohamad Win, student number 98034628, although that should all be in the description. And please fill out the peer review. And once again, thanks for watching.